So in this video, we're going to talk a little bit more about perfect competition. And what we're going to really get into are what are the four different kinds of positions that a perfectly competitive firm could find itself in. So first off, to know a little bit about perfect competition, some of this is a review of last unit, but firms are price takers, and that's meaning that they take the price from the market. We also know that because of that, the marginal revenue of a firm is the same as the firm's demand curve, or that is to say the demand for the firm's products. It's the same as the average revenue for the firm's products, and it's the same as the price that the firm sees. We also know that marginal cost is the firm's supply curve, so that's from last unit as well. Now, two new things, perfective efficiency and allocative efficiency. And we're going to find that in equilibrium, perfectly competitive firms are allocatively efficient and productively efficient. Allocatively efficient just means that the quantity where they're producing is also one where the demand is equal to the price. And we're going to find that that's always true with perfectly competitive firms because we know Mr. DARP is true. And if Mr. DARP is true, the DARP portion of it means that we're always going to be producing at a quantity where demand equals price. We'll find in later sections when we're looking at monopolies and monopolistic competition and oligopolies that that's not true. Productive efficiency is actually not always achieved. So in perfectly competitive firms, they are going to be productively efficient only in equilibrium. But what they are not going to be productively efficient in these other short-run scenarios that we're going to look at. Now, what does it mean? It means that they're producing at a quantity where the output is at the minimum ATC value, right? That bottom of the U. And we'll see it in this picture that we're about to draw, but not in the pictures afterwards. So let's go ahead and get started. So first we need a market in equilibrium, and we're going to do two side-by-side graphs of the industry, or the market, and the firm. And we have a downward sloping demand curve for the market, upward sloping supply curve, and we're going to set a market price. And we know that we continue that over here because this firm is a price taker. So we know that this is the marginal revenue of the firm, but it's also the demand curve for the firm, so I'm going to put DF there. It's equal to the average revenue, and it's equal to the price that the firm receives. We know that this quantity is the market quantity, and then we're going to add some of the cost curves from last unit onto this graph. So first we always draw the marginal cost curve, and we know that that's equivalent to the firm's supply curve. Then we're going to go down, hit where the two lines cross each other. So now we have three lines all at once, put a dot, and come back up again. And that's going to be ATC. Now, in the long run, right, we notice in this equilibrium, we're going to be producing where MR equals MC. Now, where is that? Well, we go down the MC till we get to the MR line, and that's the point where they equal each other. So this is the quantity that the firm produces. Now, is that at the minimum of ATC? Yes, it is. So we can say, yes, it is productively efficient. Now, we're also going to graph one more line on here. The third cost curve that's important for us is AVC. So it's going to come down. It's going to be below the ATC. We learned that in the last unit. And then it's going to come back up again. And we know that they get closer and closer and closer. That is ATC and AVC, because the distance between the two is AFC. Now, we're not going to draw an AFC curve on this one, but we do need to know that the vertical distance between those two is AFC. And now we're all done with perfect competition and equilibrium. Now, next page we're going to do is what does it look like when a firm starts to earn a profit? So we're going to start with a market and a firm in equilibrium, and then we're going to show what happens when demand increases. And we're going to find that the firm starts to earn a profit. So we're going to get some practice here in drawing these in equilibrium. So we're going to do that actually, we're going to do that 4 times. So the first one was just to leave it at equilibrium, but here we do the same thing we did last time. We have MR, demand, average revenue price. That's the market price. That's the market quantity. Come up, marginal cost, down, hit that line, and come back up again, ATC. Down, hit that line, come back up again, AVC. Now, it tells us demand's going to increase. So we're going to start, what's that one thing here? Quantity firm. So that's the quantity because they're going to produce where MR equals MC. And it's a little hard to see now with all the lines on here, but MR all the way over to the MC line is right here. So now we're going to start with demand increasing. So we're going to draw a rightward shift of demand. Right? Demand shifts to the right. So what happens in the market? Well, you have an increased quantity and we have an increased price. Right? Higher price, higher quantity. Well, what that causes is a new Mr. Darp. New Mr. Darp, right? So he's all the way over here, this Mr. Darp. And I'm just going to label him MR1 and demand curve 1, and we know that that's a higher price, right? The price that the firm receives is going to be higher. So our new Mr. Darp. Now we got something else going on. Remember, we're always looking where MR equals MC. Produce at the quantity at MR equals MC. So now, where does MR equals MC? Well, the new MR curve, all the way over, equals MC here. Right? MR equals MC. And now we're going to draw a line down. Down. That's the quantity that the firm produces. And that should make sense, right? The firm is producing more, the market has a little bit more here. But now we have to observe something. Price is up here. P is way up here. But the ATC, the average total cost of a unit, is here at that quantity, right? So notice that there's a distance between price and ATC here, and it's a little bit hard to see, so I'm going to zoom in even a little bit more so that you can really see that picture. You can see now that the marginal revenue is higher than the ATC. And so if we observe that, price greater than ATC, that means we have a profit. That means we have a profit. And the profit per unit is the vertical distance between those two. The amount of the total amount of profit is that rectangle. We go from the ATC over, and we can shade that rectangle, and that rectangle is the amount of profit. So we're going from the price to the ATC at this new quantity, and we go all the way over, and that rectangle is the amount of profit. So we're always going to be comparing price to ATC when we're looking for profit and for loss. Okay. So now we're going to do the other one here. We're going to do losses, but in this one we're going to see them still. We're going to still operate, but at a loss. Now, this is where we're going to introduce something called the shutdown rule. And the shutdown rule is pretty simple. All it means is that if Mr. Darp, that is to say the price, falls below the ATC, then we know we're losing money, right? So if price is less than ATC, we know we're losing money. But if price is greater than AVC, they should still operate. So they should operate temporarily to cover their fixed costs despite their losses. Now, it may sound a little counterintuitive. You'd go, why would the firm operate? Why would they operate even though they're losing money? Think about a restaurant at 3 o'clock in the afternoon. They might have some customers who are coming in, and so they're going to be open at 3 o'clock in the afternoon even though they aren't earning a profit because they make enough money. And here's the important part. They make enough money to cover all of their fixed costs and a little bit of their variable cost. If they operate, right, they're going to lose less money than if they shut down. If they shut down, they lose all of their fixed cost. And so then they're really in a worse spot. So they're going to operate temporarily at a loss. Now, this only is going to be in the short run. In the long run, if this were a permanent situation, the firm should exit the market, right? But they can't do that, right? Today's like a Tuesday at 3 o'clock. They can't sell off their entire business at Tuesday at 3 o'clock. They have to decide, do we operate at a loss just for temporarily, or do we shut down? And that's where they're going to make that decision based on the shutdown rule. And the shutdown rule is actually even more simply stated, is that you shut if price falls below AVC. Right? If the price falls below AVC. Now, if the price is above the AVC, as we have here, then they should operate at a loss. They shouldn't shut down. We're going to see that here in this picture. So first, we're going to start with price and quantity in the market, and then we're going to do over here price and quantity in the firm, and up supply, and we're going to try to connect that. My pen is starting to die on me here. And we know that that's the market price, right? And that market price and market quantity, right? Market price, market quantity. And then we're going to find that that creates the marginal revenue and demand and average revenue and price, the Mr. DARP. And then we know we've got marginal cost, and then we've got come down, come back up, ATC, and then come down and come back up, AVC. So this is why we need that AVC curve in here. So let's imagine a scenario where demand decreases, and so what's going to happen, right, is demand's going to fall. We'll say it falls to right about here. Demand falls, and we get a new price and a quantity, and we know the quantity is smaller and the price is lower. Now, this new price, right, I go all the way over here, gives us a new Mr. DARP. Mr. DARP number 2, right? Or in this case, I'm numbering them as number 1, sorry. So MR1 equals demand 1 equals price down. So this actually is shifting down. Just like up here, Mr. DARP actually shifted up, right? The Mr. DARP moved up. Now Mr. DARP has moved down. Now we used to be MR equals MC. We used to be here at that quantity. But the new amount is the MC to the new MR curve. The new MR curve, which is here. Quantity here. So we notice that the firm is going to produce a little bit less. Now, here's an important safety tip, right? Up here, we compared the new Mr. DARP to the average total cost. So we looked at new Mr. DARP to the average total cost. We're going to do the exact same thing down here. We're going to look for the new Mr. DARP at the quantity that we're producing at to the average total cost. Well, it's not down because that's AVC. It's up. So we're going to go all the way up and stop at the ATC up here. And that amount, that vertical distance between those two, is the per unit amount of the loss. We went from marginal revenue number 1, the new Mr. DARP, all the way up to the ATC. And we found that price, in this case, was less than ATC, so we're earning a loss. Right? And if the ATC is way up here and price is down here, the per unit amount of the loss is that vertical distance. Now, how much is the total loss? Well, if this is the per unit, if we multiply it by the quantity, right, that amount, then we're going to get a rectangle as well. So we're going to connect that over. We're going to connect that over, and this over, and this box is our loss rectangle. Now, this firm is going to earn that loss in the short run, right? In the short run. But if they chose to shut down, well, they'd still lose their fixed costs. The shutting down, maybe an important part here, is that they're not exiting the market if they shut down. They're just deciding we're not going to produce anything. So if they actually produced, or if they shut down, if this firm had shut down, then they would go, they'd have their AVC and their ATC like that, right? And let's say we know that they're producing like right here, right? That's the new Q1. Let's say they went ahead and shut down. Well, what would they lose? They'd actually lose the distance between the ATC and the AVC over. So they'd lose a lot more. Now on this graph, it would actually go all the way down to here. If they shut down, then it would actually include this little portion, this little portion right here, plus all the other stuff. So they'd rather lose the smaller box, right, than the entire box that includes all of that stuff. So they don't want to lose the big box, they'd want to lose the smaller box. And we're going to do some practice problems later that'll help us understand that a little bit more. But in short, if the price is between the AVC and the ATC, then they're going to keep operating in the short run despite losses. Now we're going to do the last problem, and then maybe it might be a little bit more clear. So for this one, okay, I'm going to draw the same graph in equilibrium. Okay, and then we're going to move out of it again But we're going to make in this one Mr. Darp go so low that the firm does choose to shut down. So here's Mr. Darp, original Mr. Darp, and marginal cost, and ATC, so price in the market, quantity in the market, and then we're going to have ATC, or sorry, AVC. Okay, and now we know that originally the firm is here, QF. We're going to say demand falls, but we're going to make it fall really low. We're going to say demand goes really low, way small, way shifts to the left, right? So the new quantity in the market's a lot smaller, and the new price is way lower. Well, what's that do? It makes Mr. Darp way lower. So our new Mr. Darp is way down, and that right there doesn't matter if it connects there or not. That's a little coincidence. So Mr. Darp shifts way far down, MR1, D1, P1, right? Because the price fell pretty far, PF1 down to P1. Now in this one, the firm's just going to shut down. Okay, this one, the firm, because price is below AVC, they're going to shut down, and here's why. So this is something that you can actually watch Jacob Clifford explain this as well, and he does it pretty quickly, and we're going to do a practice problem with it. But let's assign some values to this to see what ends up happening. Let's say they went ahead and did produce. So MR here and MC here. So we'll assign this new price, like that value we'll say is $5. And then we'll say that the quantity here is 10. Okay, the quantity here is 10. So the total revenue at P1 and that quantity of 10 where they'd be producing is TR equals 5 times 10 is 50. Now what's their total cost? Well, it's going to be at that 10 all the way up to the ATC, and we need a value, so I'm just going to assign, say, make it $12, right? $12. So their total cost, and this is just to remember, ATC is times the quantity. That tells us total cost. So that's at 10 is the quantity, so 10 times, what's the ATC up here? 12. So therefore it's 120. Now that's if they operate, right? That's what they lose is 50 minus 120. So they lose 70 if they operate. Now if they shut down, all they're going to lose are their fixed costs. And we can find the fixed cost because the fixed cost equals AFC times the quantity that we're producing at. So the average fixed cost, well, at the quantity, we'll say the quantity is 10. If we go up here, this value to this value, the vertical distance between the ATC and the AVC, the vertical distance here, from here to here, right, from here to here, is what we call the AFC. We remember that? I told you it'd be important. So that's the AFC. So we'll say that over is 7, so the vertical distance is 5 between those. So 5 times 10, then they're going to lose 50. If they shut down, their loss is only the 50 right here. Now, if they operated, they would lose all of this stuff. They would lose all of this. It'd be way bigger, right? So if they operate, they lose 70. If they shut down, they only lose 50. And so they're going to choose to shut down temporarily and only incur this smaller top half of that rectangle. So hopefully this helps you understand a little bit more of how these different market structures operate, or how perfectly competitive markets and firms operate in different scenarios. I'll see you next time.